So a lot of you guys are doing great. Don't have any missing assignments. You're staying right on top of things. But there's some of you that are just missing. And some of them, some people are missing stuff from like a month or two ago, and you've done everything since then. It's like you just skipped something. Let's talk about the end of the semester since we're now at Star Wars Day here. May the 4th be with you. Um, we don't have much time left of school. Finals are like 2.5 weeks from now, on that Friday, the 22nd, is when finals begin. In fact, let me see when the class final. This class is scheduled for noon on Friday, the 22nd. Yes, at noon will be our final in 2.5 weeks. So, for final exams, you can be exempt this semester. You can't in the fall. In the fall, you have to take this class. This is a required final. But in the spring, you have the option to not have to take the final. Now let's go over the requirements again, because it's always good to remind those. And I've posted those on the front page there in Google Classroom. I have an attachment. You can click on it and see all the requirements. But we can go over them. First and foremost, and I think it's listed last on that list, advisory, 6th period. You cannot have more than 4 absences. Pretty much, period. If you have more than 4 absences in advisory, you have to take every final. I don't even have to look to see if you're exempt. All I do is I get a report that says, oh, this person had 6 absences advisory. It's like, oh, okay, I don't have to check anything then. They have to take the final. All the teachers, oh, well, they have to take the final. So hopefully you've been going to your advisory class. But let's assume you have 4 or less absences in advisory, or tardies as well. Then I'll check to see for this class. No more than 4 absences in this class. Tardies have changed just a little bit. It's always been no more than 4 absences, no more than 4 tardies. But now, last month, made some adjustments to that. You can have up to 8 tardies. But tardies and absences together cannot total more than 8. Like, what does that mean? That means if you have 8 tardies, you have to have 0 absences, because 0 plus 8 equals 8. If you have 6 tardies, you could have 2 absences and still be exempt. But if you had 3 absences and 6 tardies, that adds up to 9. That's over the limit. You can't. So it's easiest just to think of 4 of each: 4 absences, 4 tardies. But if you add to the tardies, you have to take away from the absences, because total of 8 together. If you have 6 tardies, that means you only have 2 absences. So just think of keeping it under 4 in both. It's easy. So that's the requirement for attendance. Then you cannot have any missing assignments. If you have 1 missing assignment from January, you got to take the final. Nothing else matters. Doesn't matter if you've had perfect attendance. Everything else has been 100%. You've been doing great. You still have a missing assignment. You're taking the final. So this is a good time to go back, look at the grade screen and say, ooh, am I missing anything? Because I want to make sure and get everything turned in. And then, well, no fines or fees, but this class does not have fines or fees. The other thing, the only other requirement besides absences on it is your grade has to be at least 75%. If your grade's below 75%, then you have to take the final. Even if you have no absences, you've turned everything in, no tardies, perfect attendance advisory, all that, but your grade's 74%, you have to take the final. Now, saying that, most of you, I'm saying the huge majority, are over 75%. So grade is not going to be a huge factor for many of you at all. But that missing assignment could be, because looking at, I see there are, what, 1, 2, 3, like 4, 5, 6 people that never turned in part 2 of our first unit back in January. We had the test. It was part 1 and part 2. Did everyone? Just about everyone. Yeah, part 1 wasn't a big issue. People turned in part 1. They just skipped part 2 because I had to do work. I have to type my answers. I have to show my work. I'm not going to do that. Okay, take the final. You haven't done that, take the final. That's what it means. If you don't want to take the final, you need to go back and review that unit because we haven't looked at that in months. You've forgotten a lot, but you need to go back and take part 2 of that test. I've got it open so you can make up any work from the semester now. Uh, and there's, like I say, there's like half a dozen of you folks that are going to have to take the final just because you never turned in an assignment from way back in February or January. See, when was that due? February 15th was when that was due. So that's it with finals. Just getting everyone up to date. I have not got the report because we still have a couple of weeks of classes here. It'll probably be 2 weeks from now before they send me the absence report. Okay, here's the final absence report. Now you can see. So, but our final is on that Friday, 2 weeks from now. So I'll get that report early in the week and to be emailing everybody, hey, you don't have to take the final, or hey, you do have to take the final, however it falls. And hopefully, most all of you are exempt. Now, if you're a senior, and we do have seniors in this class, our finals are next Monday and Tuesday during your regular classes. So if you are taking the final next week, and I should have that email out this week. They haven't sent me the senior absence report either. I'll have that out this week, and you'll get an email. But just come to class, and I'll put a breakout room, and you'll be taking the final during the class period next week. So. All right, let's pull it up and see what we look at this week. Like I said, this week's a lot easier. We've been doing all of this work in the last couple of weeks, just taking up our whole class period. I don't think we're going to be here the whole class period this time, just because we don't have as much to cover as we have been. Let's see, third period, Algebra 2, right there. Going to that grade screen. By the way, if your grade's below 75%, you're trying to figure out what do I need to do to get above it. Go to the grade screen, and right up here is a what if. You can say, what if? You can say, oh, what if I get, well, let's see, on the final, what if I get a 75%? Recalculate. Or say, well, if I got a 75%, here's what my grade would be. And you can go through any grade, like if you had a 0 on 3 assignments here. Let's take these 3 assignments and make them all zeros. And we'll say this one. This one's 0. If I got zeros on all those assignments, now my grade's an 83.5. It's like, what do I need to make to get to a 90? Well, what if I make a 50% on this one? Oh, I'm at 87. What do I need to make on this one? Let's see. What if I make a 50% on this assignment? I'm at an 88.8. So you can go this what if and play around with it, change grades. Like if I redo this assignment and I get 80%, what's my grade going to be? But don't forget, if you have to take the final, you might want to put a grade in for the final, what you think you're going to make there, because that can affect it too. Or you can just say, I'll put something in for the final, see what I need to score. But anyway, oh, it looks like I did not. Oh, no, I did turn in. We've been doing all the arithmetic stuff. So let's go back to the grade screen here. Last week was geometric sequences and series. The week before that was arithmetic sequences and series. This week, we just have one assignment, and it's graphing. Graphing. This is going to be using Desmos. We're not going to graph them by hand, but we're going to talk about graphing 7.05. And then seniors have the final. The rest of us will test on sequences and series next week. Seniors just have the semester final. So let's look at our graphing lesson 7.05. So I have the semester final on here. When you click on it, you gotta have a password to take it. So you can't do the final early. But information at your fingertips. In today's always online world, news and data travel faster than ever. Information has become increasingly valuable, and it's important to be able to decipher and communicate data in various formats. Infographics, information graphics that contain information, charts, etc., fill the internet because displaying data graphically helps others see the patterns, the connections, the big picture of everything. So graphing a sequence or series can also serve that same purpose. Make it easy to see the patterns, etc. So after this lesson, you'll be able to answer the following questions. What key features are unique to the graphs of sequences and series? And how can the average rate of change be found using a discrete graph? That's always a good one. We talk about the average rate of change all the time in algebra. Let's look at the restrictions. Remember, we talked about the restrictions on the domain and range for arithmetic and geometric. It was the same thing. Let's see if you remember what it was. The domain is restricted to integers greater than or equal to 1 because it is the term number. We don't have a 0 term. We don't have a -3 term. We don't have a 2.5 term. We just have 1, 2, 3, 4, 5. So domain is always integers greater than or equal to 1. Right? The range just depends on what your sequence is. It has little to no restrictions at all. It can be positive numbers. It can be negative numbers. It can be 0. It can be decimal numbers. It can be fractions. But it depends on the situation. Now, if you have a situation like how many ostrich eggs there are, as the ostriches lay more and more eggs, we would never have negative 23.27 ostrich eggs. In that case, the situation determines where the restrictions are. But in general, a sequence or series can have any numbers at all as the range. Discrete versus continuous. Due to the limits of the domain, graphs of sequences and series are discrete, which means they are not connected. It's just the points. They exist only at specific values. It's not like a continuous linear function. See, if you have a continuous graph, everything's connected with a line, which means every point on that line exists for the problem. With a discrete graph, the first term is 2, the second term is 3. There's nothing in between there. Because in a sequence, you have the first term and the second term and the third term, but you don't have any terms in between those. So that's why you graph it with only the points. So graphing a sequence using technology. It's important to note where it'll show up. You may want to move or resize the viewing window so we can see everything. Investigate whether the graphing program of your choice will accept a sequence. So a manual method is just graphing the points. The sequence is 1, 3, 5, 7. You plot 1, 1, 2, 3, 3, 5, 4, 7. Okay, average rate of change. This can be calculated in the same manner it's been done for all the other functions. There is the change of slope formula, the slope formula, not the change of slope, the slope formula. It's m is slope, y2 minus y1 divided by x2 minus x1. It's just how much of the y's change over how much of the x's change. And we'll look at an average rate of change. Let's look at page 3. Let's see if they want us to start doing some here. Graphing arithmetic sequence. All right. Bart has been keeping track of people who say that they're coming to his birthday party next week. He got 3 replies the first day. Since then, he's gotten 5 more responses than the day before. Create the explicit equation that determines the number of responses he got, A sub n, and then graph the sequence. So let me fire up our camera so we can figure out what that's going to look like. Okay, so what was going on with this? 3 replies on the first day and 5 more than the day before. So he started with 3. That's his first day's response. And common difference is 5. So if we want to find a term, we can take the first term plus common difference times n minus 1. Or is it a sub n minus 1, right? It's the term before it. No, just times n minus 1. We're doing the explicit formula. So if we want to know what question are they asking? I didn't look at that. Create explicit equation term. Okay, it's just the equation. They haven't asked for a specific day yet. So for this specific one, a sub n equals 3. plus 5n minus 1. Now we can simplify this. A sub n equals 3 plus 5n minus 5. So what I did, I got rid of the parentheses. So then a sub n equals 3 minus 5. Those are like terms. So let's just put the 5 in first. 5n minus 2. Because 3 and negative 5 equals negative 2. So this is what our equation for our graph will look. Now we can use x's instead of n. Let's see. I'm not sure if Desmos would like it with an n. 5n minus 2. Does it do that? No, it doesn't really. Okay, let's change those to x's. Okay, now the problem with this, though, is it has a continuous line. So let's try this. Let's make it a table. Okay, and y is going to equal 5n minus 2. And so for each term, 5x minus 2. I keep putting that in there. So let's see, 5x minus 2. First one would be 3, right? Y equals, does that do it? Table headers must be simple expressions. Equations are not allowed. Okay, so if I take that off, now what's it say? Too many variables, try defining x. Can I put 5? Oh, there it is. If I take this to just be x instead of x sub 1. So now, since I made it a table and I put x, which is the term number, and over here I put what the simplified expression was, which we had to calculate and figure out, using a1 plus dn minus 1, substituting in a1 and substituting in d, simplifying that to just 5n minus 2. Now we get the graph of that sequence, just at least the first 5 terms. I can continue adding more terms, just adding them to my table. I got the first 7 terms. So you see all of those. But Desmos can do a graph if we set it up as a table with x and use 5x minus 2 or whatever it is. Instead of n, use x. And Desmos is happy to graph that for us. So let's see. They do the same thing. They take a sub 1 plus dn minus 1, substitute in the 3 and the 5, distribute the 5 to get rid of the parentheses, and then you've got the 3 and the negative 5 you can combine. And then we put it in the graph. Now there's their x and y. It looks slanted different because ours is just bigger. They changed the settings to say, okay, the x-axis would just be from negative 10 to 10. See, now it's not as steep because we spread it out. So that's very similar to what theirs is. The space between there is not part of the sequence, just like it is not graphed in ours on Desmos either. All right, let's look at example 2. Mandy took some stale bread down to the pond to feed the ducks. On the first day she went, there were 4 ducks. All right, let me write this down. First day, 4 ducks. The news spread throughout the duck community quickly, because you know how the duck community is. Man, rumors just run. Oh, and the next day there were 11 ducks. And the next day there were 18 ducks. And Mandy's got concerned she won't bring enough bread. Help her by graphing the sequence for the first 8 terms. Okay. A sub 1 is 4. 4, 11, 18, and they want 8 terms. So let's see. A sub 8 terms. But see, a sub n would be 4, because we're doing the same formula, because we're going to graph it and use the graph to figure this out. Plus dn minus 1. Plus, what's d? Well, if it goes from 4 to 11, 11, 18, that's 7 n minus 1. So 4 plus 7n minus 7. We have like terms, because we have the minus 7 and the plus 4. So a sub n equals 7n minus 3. So this is what we're going to graph with, 7n minus 3. We're going to change it to an x for Desmos. 7x minus 3. Okay, here is our new graph. And we need to go 8 terms. So 4, 11, 18. There will be 53 ducks on day 8 if the ducks continue spreading the word as they have up to this point. 53 ducks. So this tells how many every day are showing up there. We go down the scale. But we start with the 4, then the 11, then the 18, and it just continues growing up all the way up to the 53rd. Check your work. Day 8 could be right up here at 53. Look at all the unconnected dots. Perfect. So that is what the graph looks like. Just like ours here. All right. Graphing in geometric sequence. So let's write down that formula that we're using for that. A sub n equals a sub 1 times r raised to the power of n minus 1. All right. Wyatt earned 80 points on a recent project. His instructor allows Wyatt to earn 1/10 of the points earned by doing some revisions. Wyatt can resubmit his project up to 9 times, and every time he can earn an extra 1/10 of the points that he earned on the submission before. So if he earned 80 points the first time, that means when he submits again and gets 1/10 of that, he can get up to 8 points the second time by fixing things and resubmitting it. Create the explicit equation that determines the points on each submission that on each submission Wyatt earns, A sub n, and then graph the sequence. 1/10 the points. Okay, so I just want to see, is this going up or down? All right, it is going down. So let's talk this through here. He got 80 points when he first turned it in. So that's our A sub 1. He can get 1/10. 1/10 is 0.1. 1/10. So for the formula, A sub n equals 80.1 n minus 1. And he can resubmit it up to 9 times. But let's put this in as our y. There's nothing to really simplify there. But let's go to our Desmos, change this to 80 times 0.1 raised to the power of x minus 1. Zoom out a little bit because the 80 is way up here. The first time he turns it in, he get 80. Now, if he turns it in again with some corrections on it, he can get 1/10 of those points. So the second time, he can get 8 more points. Then the third time, he can get 1/10 of 8. So he can get 0.8 points. And then 0.08 points, and then 0.008 points, and then 0.00. Each time, you can just get 1/10 of what he got before. Where finally, on the last one, this ain't even going to show it because it's 0.000008. It just rounded it up. It rounded up that last one because this was the 7th one. And they wanted to go 9 submissions, didn't they? So 9 submissions is it's got to be zoomed in to even tell us anything because it's such a small number. Oh, see, as we zoom in, it's starting to give us the fraction. There it is. 6 zeros with an 8. It's a little bitty number. So when they substitute the information in, got the 80.1 n minus 1. That's what we put in our Desmos graph. And the graph looks like this. There's the 80, there's the 8, there's the 0.8, and then there's all the little bitty numbers that are really, really close to 0, just like ours right here. Let me zoom back out. So we have the same numbers right there. Whew. So they got the minor grid lines. No minors. That looks just like what they have right here. Okay, let's look at example 4. Each year that Zoe leaves her money in the bank account, it's 103% larger than it was last year because she gets 3% interest. She initially put in $1,500. Okay, so A sub 1 is $1,500 and 103%. Every year is 103% over what there was last time. They want to know for 7 years. So after 7 years, how much money she's going to have. Okay, using the same formula, A sub n equals 1,500. Now we got to put R as a decimal. If it's 103%, that's 1.03. Because 100% is just 1. So this is what we want to graph. And then we'll see what year 7 puts us at. 1.03. Okay, we're starting amount is 1,500. Go away. 1,500. And this is 1.03. So year 7, she should have like $1,791. Let's zoom out of our graph because we're way up here. Year 7, there it is. She should have $1,791 by year. Starts with $1,500 and grows 3% per year. By the 7th year, she's gained almost $300 extra dollars. So what they get? 175. Yeah, that's 1,500. That's over 1,750. Ours is over 1,750. It's 1,791. So that is the same thing. They just scale it differently. Very good. All right, let's look at page 4. We're learning how to graph this with Desmos with a table, just like that. Graphing an arithmetic or geometric series. Now, of course, the series is when all the numbers are being added together. That was a sequence. We were graphing a sequence there. Arithmetic series formula and geometric series formula. So these are the formulas we're using. The ones that just use the first term. Both of these just use the first term and the common ratio or the common difference. This is not the ones that use the first and last term. So let's see here. Bart has been keeping track of people who say they're coming to his birthday party. He got 3 replies. So we want a formula now that calculates the total number. We were calculating how many responses he's getting each day. So we need to use the arithmetic series formula. So let's change to that. We're going to have some simplifying to do this time, that's for sure. So he gets 3 and then got 5 more every day. So A1 is 3, the common difference is 5. So S sub n equals n divided by 2 times 2 times the first day. So that's 6 because the first day was 3. Plus d 5 times n minus 1. Okay. N divided by 2. 6 plus 5n minus 5. N divided by 2. 5n 6 minus 5. All right. Now We can leave it like that. I wonder if they simplified it anymore. Let's see if we can just graph it as it is. X divided by 2 times parentheses 5n plus 1. Let's try that. No need to go further than we have to. All right, so this will be x divided by 2. Oh, it didn't delete the rest of that. Divided by. Oh, what's it doing? There it is. Okay, x divided by 2 times, we said 5x plus 1. 5x plus 1. Okay, it gave us numbers. The first day he got 3. The next day he had 11 because he got 5 more. So he got 8 the second day. So 3 plus 8 is 11. And then he got 13. So yeah, that looks like that's working. Let's zoom out where we can see it since we were way up high. Wonderful. Let's see what day they want us to see. Oh, it doesn't give any specific day on there. But this is the total number he has. Like by day 5, he's had 65 people that's coming. By day 8, he better have a big party venue because if it's 8 days, he's got 164 people that said they're coming. See what they're doing? N divided by 2. Okay, they didn't simplify it any farther than we did. N over 2, 5n plus 1. Put it in the graphing software. And there's what the graph looks like, where day 8 is at 165 people. Yeah, that looks right. We've got 164 people. Whew. All right, let's go to example 2. Wyatt earns 80 points on a recent project. His instructor, oh, this is the same thing. We just need to figure out how many points he's got by the 9th term. So let's use the geographic series formula. S sub n equals a1 minus a1 r to the n over 1 minus r. Okay. So S sub n equals A1. He got an 80 on the original paper. Minus 80 times R to the n. And OR, we know what R is. He gets a 10th of a point. I mean, a 10th of what he had before. 10th over 1 minus R. Okay, let's take this and simplify what we can. Well, I don't know that we can much. So maybe we'll just put it in as it is. 80 minus 0.1 to the x over 1 minus x. Let's see if we can put it in like that in Desmos without simplifying anything. Then we'll come back and see if, well, let's see if they simplified it. Oh, the 1 minus r. That was 1 minus r. That is something I need to fix. That was 1 minus r, not 1 minus n. So this would have a number. 1 minus 0.1. That's not 1 minus x. Got to substitute both places of r. So this is over 0.9. 1 minus 0.1. So this is what we need to put in over here on this side. So that is parentheses 80 minus 80 times 0.1 raised to the x power. Like that. I guess I need a parentheses for the x. Okay, 80 minus 80 times 0.1 over the x. That looks right. All divided by 0.9. So see how many points first he had 80 points. Then he got 8 more. So he's got 88 points. Then he got 0.8 of a point. So he's at 88.8. And it should just keep adding 0.8s. So his final grade he can get, that's as close as he can get to 100, as he can get 88.8888. It just keeps repeating the 8s. Because every time he can get a 10th of what he had last time. Yeah, there it is, just like ours. Just it levels out right there. Same graph. Okay, lesson summary. Restrictions to the range and domain. Discrete graphs are what? The graphs of sequence and series are discrete. They're not connected. Here's the formulas you want to use for graphing sequences, whether it's arithmetic or geometric. Here's the formulas you want to use for series. And the only thing we have talked about is the average rate of change. All right, let's go back. Let's go back and graph one of the earlier ones. Let's do, I want to delete all this one. Let's do the original 5x minus 2. Okay, this is one of those original ones. How many was he receiving each day? Boom, boom, boom. Now, this one's an easy one. If I say, what's the average rate of change from x equals 3 to x equals 5? Average rate of change from x equals 3 to x equals 5. Well, what that's asking is, wait, let me do this. 3 equal to x plus or equal to 5. It's wanting to know what is the slope between x equals 3 and x equals 5. What's the slope of that line? That's what I ask him. It wants to know what's the average rate of change. And if it's on a graph, you can do rise over run. But there's a lot of missing numbers inside there. We're going to have to zoom in ways to figure out exactly how many rises run. But let's write down the 2 points. 313 is a point. And what's the other point? 523. If you know the 2 points, 313, 523, the slope formula is y2 minus y1 over x2 minus x1. So let's just take the bigger one and say that's going to be the 2's. So the slope between these 2 points, y2 minus y1, that's the 2 y's, right? That's the x and the y, x and the y. 5 minus 3. I subtract the y's, I subtract the x's. What does that equal? 23 minus 13, 5 minus 3. That's the slope. Now notice, since this is an arithmetic sequence, that's also common difference. We know it goes up 5 every time. We know that. So let's look at the geometric version of the same problem. So for the geometric version, what did we say that was? How many he receives each time? It was parentheses x divided by 2. And it was 5x plus 1. Yeah, that's what we had, 5x plus 1. Okay, so on this one, it's changed a little bit. Now we want to know, see, what is the third? If we're looking at the same 2 points, let's look at the same 2 points. We're between x is 3 and x is 5. It's basically that. It's wanting to know what's the slope between those 2 lines. Now notice the points themselves, there's a curve there. It's an exponential curve. I don't care about that. I want to know what is the slope between x equals 3 and x equals 5. That's what I want to know. When it says the average rate of change, that means slope. So let's figure out what the slope is. The average rate of change, that's the 2 points. 3, 23.5, 5, 63.5. We can use this formula. Slope equals y2. Subtract the 2 y's. And I can go in either direction as long as I'm consistent. Let's do it this way first. Let's say I'm going to take 23.5 minus 63.5. Like, Mr. Brock, why didn't you do bigger versus smaller? It'll end up the same. I'll show you. So since 23.5 is first, 3 has to be first. 3 minus 5. The x and the y, they have to stay together. These are both first. These are both the second numbers. What is 23.5 minus 63.5? Well, it's negative 40. If we went the other way around, 63 minus 23 is 40. The 0.5s are the same. So it's negative 40. What is 3 minus 5? Negative 2. Negative 40 over negative 2, positive 20. The slope is 20. That is the average rate of change. Average rate of change when x equals 3 to x equals 5. Use the slope formula. And that's what it's talking about right here. Here is the slope formula. M equals y2 minus y1 over x2 minus x1. Okay, they got a page of practice problems for you. Okay, graph this sequence. First term equals negative 3. How many problems are there? There's 6 here. Great. And d equals 4. So that's a sequence. We can go back to that first formula. We'll do this one together, and then we'll look at the assignment. So that first formula that was a1 plus dn minus 1. And this one says it's negative 3 with a d of 4. Let's see. Negative 3 plus a d of 4. A1, first term, common difference. Simplify, negative 3. Get rid of the parentheses. 4n minus 4. So this one will graph as 4n minus 7 because you got negative 3 and negative 4. You put those together. So let's look what that graph looks like, and then we can check it. Remember, make them x's. It won't graph right. I'll get rid of this one. Okay, this is what our graph looks like. The first term is negative 3, but it's going up 4 each time. So it's the second term is 1, 5, 9, 13, 17, 21. It's going up 4 each time. Negative 3, 1, 5, 9, 13, 17. It's going up 4 each time. 4n minus 7. That's what we came up with. That's the same graph. All right, there you go. You have 6. This, they actually give you this table. Starts at 14, then goes 11, then goes 8. So you got to figure out what the formula is. It gives you the first 3 points. Gives you the first term and the common ratio. Again, the first 3 terms, and this is a geometric because it's not the same each time. All right, let's look at our assignment that goes with it this week. Calculate the average rate of change from n equals 2 to 6. So from this point right here, which is 214, let's see if I can put it over here. That's the second point, and the 6 points over here. So from here to here, what's the average slope? It's the average slope. And it's one of these. Here's another average rate of change. This time from n equals 2 to n equals 4. N equals 2 to n equals 4. If you drew a straight line, what would the slope be? But there's the values, so you can use that formula. There's the values of 2, and there's the value of 4. Graph the first 6 terms where here's the first term and there's the common difference. So which one of these 4 graphs would graph that? Well, I'll tell you, Look at the common difference. The common difference is 3. It's a positive 3. 2 of these graphs are going up. 2 of the graphs are going down. You should be able to eliminate 2 of them real quick. So the thing to check for, which one has the first term correctly and which one has the right slope of 3. Okay, this one, graph the first 6 terms of this where A1 equals 4 and R equals 2. It's geometric. So make sure it starts with the right first term and make sure it goes up. And you can figure out what the next term is. You can figure out what the term after that is and say, is that the points? Is that the points it's graphing? So there you go. Graph the 6 terms where the first term is 5 and the R is 1.25. That's it. 4 choices, 5 problems. All about the graphing. All about the graphing. Okie dokie. That's it. We're done with the unit here. Next week, we'll test over this. Seniors will just have the semester final unless they're exempt next week. So we are about into summer, guys, because we're running out of lessons. This was our last lesson of the semester. So, all right, get this one turned in. If you're behind on anything, like I said, get all those past things turned in so you have a shot at exemption if your attendance has been well. So otherwise, this is a normal schedule this week. So I'll have class again Wednesday afternoon if anyone needs any help with anything. So we'll see you later.